In this video, we're going to learn how to solve problems involving horizontal and vertical asymptotes with function easily and fast. After going through this video, I guarantee you that you'll be able to solve problems involving horizontal and vertical asymptotes. So ensure you stay with me to the very end of this video, okay? Having known that, let's go into the details of this video. So let's begin with horizontal asymptotes. Let's say we are given this function f of x equals x squared plus 2 over x minus 4. Now, if you are given this function, it has to find the horizontal asymptote. How we do it? Now, I'm going to show you or tell you how you can just do it fast in a matter of seconds. Now, for horizontal asymptotes, the principles that are applied to solving in limit at infinity are also applied to it, of which for that of a limit of a function at infinity, it has three principles that guide it. The same thing that is applicable here. The first principle states that when the highest power of the numerator is greater than that of the denominator, the limit of the function will be indeterminate, does not exist. But in this case, since, as you can see, the highest power of x here is 2, the numerator, whereas at the denominator we have it to be 1. The highest power of x here is 1, invisible. So since the numerator is higher than the denominator, this function is said to have no horizontal asymptote. So the answer will be that the function does not have horizontal asymptotes. Now, what if this question is this other way? Let's say this time around we have something like x plus 2, okay, over x squared minus 4. Now, in this case, you can see that the highest power of the denominator is now higher than that of the numerator. The highest power of the denominator here is 2, that of the numerator is 1. In this case, the answer to this question, if we are using the principle of limit at infinity, when the denominator value power is higher than that of the numerator power, the limit of that function will say to be 0. So the answer to this question will be 0. The horizontal asymptote of this function will be 0. Now, what if the powers are the same? Let's say you have something like this x squared plus 2 over x squared minus 4. Now, in this case, for limit at infinity of rational function, when the both powers are the same, you take the coefficient of both sides. Like in this situation, the highest power of x here is 2, the highest power of x here is also 2. So since they are the same, take their coefficients. So the coefficient of s squared here is 1. Coefficient of s squared is also 1. So 1 over 1 is given what 1. So the horizontal asymptote of the function is what 1. It's as simple as that, guys. Very, very simple and save time. So that's for horizontal asymptotes. Now let's go back to vertical asymptotes, which is a bit technical but very easy. I'm going to show you guys. Now, let me use this example and illustrate. Let me begin with this example. Yeah, I'll give you something like this. X plus 2 is x over x squared minus 4. I have to find a vertical asymptote. Now, in vertical asymptote, that's what we call whole. Yeah, that's what we call whole. Now, I'm going to explain. Follow me, guys. For vertical asymptotes, what we are trying to look at or do is to get factors that will cancel out each other, get common factors that will cancel out each other, of which this question, we can get the common factor at the denominator that will cancel out the numerator. So let's solve it together, guys. Over, we have x, when you factorize the denominator, we're going to have x plus 2 in brackets x minus 2. Okay, so as you can see, we have common factors. This will cancel what we have here. Now, for the whole of this function, this factor that cancel that, you equate it to 0. Now, so make the subject formula. Therefore, the whole of the function give you negative 2, that minus 2. Whereas the vertical asymptote will be the factor that didn't cancel out, which is x minus 2 equals 0. So when you make x the subject formula, it will give you x equals about 2. So for this question, we have the vertical asymptote to be 2 and the whole of the function. to be what? -2 respectively. Okay guys, so let's look at another example. Let's look at this example. I do something like 3x plus 1 over x squared minus 4. Okay, now in this case, let's check. I don't think there's we have a common factor that we cancel each other, but let's solve it together. Take x plus 1 over x. When you factorize it, you're going to have x minus, okay, let's start with plus x plus 2 in bracket x minus 2. Okay, now we're going to have, as you can see, there's no common factor to cancel out. Now in this case, this function we have, let's say f of x, because in this case, this function we have two vertical asymptotes, so you equate the respective values to 0. So we have x plus 2 equals 0 and x minus 2 equals 0. So when you get the respective change of solid formula or solid formula, you're going to have x equals -2 and x equals 2. So the vertical asymptotes of this function will be -2 or 2, or you can say that they have two vertical asymptotes which are -2 and 2 respectively. So let me show you one more example before we call it a class. Okay, so once you're giving something like this, we have question of this format, f of x equals 4x squared over s squared plus 8. Okay, so in this situation, I feel nothing will be able to cancel out, but let's check. As you can see, looking at this question, you cannot factorize the denominator values. So since when you cannot factorize the denominator values, what you have to do, equate it to 0. So you're going to have x squared plus 8 equals 0. Okay, now let's check. I think this function won't have a vertical asymptote, but let's see if we're going to get no value. If we're not able to get a value, that means the function won't have or doesn't have a vertical asymptote rather. So let's make a the formula s squared equals -8 times minus 8. So to make it a standard formula, you square both sides. So this square, that means x will be, you cannot find the square root of a negative number. When you punch a calculator, you're going to have syntax error. So it does not exist. That means this function does not have a vertical asymptote. The answer will be no vertical asymptotes. So guys, these are basically how you can solve problems involving horizontal asymptote and vertical asymptotes of a function. I hope you learned something interesting. And with this, we are come to the end of the class. If you're new to the channel, you should hit the subscribe button to subscribe to the channel for more videos from us. Also like, share, and comment on this video. Tell me how you feel regarding what you learned from this class. If you seem to have any specific question to ask regarding what I have taught or explained in this class, feel free to leave your question in the comment section below, and I'll be sure to give you a response. That's it for this class, guys. Thanks for watching. See you in my subsequent video.